If you zoom out far enough, our entire history, every war, every empire, every love story, and every quiet breath exists on a speck of dust suspended in a hostile, freezing void. We look at our blue skies and calm oceans and assume safety is the default state of the cosmos. We are wrong. To look out into the cosmos is to look into a shooting gallery of epic proportions. The universe does not love life. In fact, it seems actively designed to erase it. Every single second, our planet stands in the crosshairs of a cosmic firing squad. Rogue black holes, wandering blindly through the stellar nursery, sterilizing beams of cosmic radiation traveling at the speed of light. Rogue planets capable of tearing our solar system apart. When astrobiologists calculate the probability of a planet sustaining life for over 4.5 times 10 to the power of 9 years without being completely sterilized by a random cosmic cataclysm, the number they get is agonizingly close to zero. The mathematical odds are stacked against us like a house of cards in a hurricane. And yet, here we are, breathing, thinking, surviving. Is it just an unbelievable stroke of luck, or is there a silent, complex security system built into the cosmos itself to keep us alive? To understand this mystery, we must first go back to a time before the dinosaurs, a time when Earth was threatened not by the stars, but by the very life it tried to nurture. Long before the first asteroid hit or the first volcano erupted, Earth faced its very first extinction event, and the killer wasn't an asteroid. It was a microscopic, innocent-looking organism known as cyanobacteria. Around 2.4 times 10 to the power of 9 years ago, these tiny organisms figured out a new way to harvest energy. Photosynthesis. They began consuming carbon dioxide and releasing a highly reactive, toxic gas into the environment. That gas was oxygen. To the anaerobic life that dominated the planet, oxygen was a lethal poison. This was the Great Oxygenation Event, the world's first mass extinction, triggered entirely by biological success. But the crisis didn't stop there. The newly introduced oxygen reacted with the abundant methane in the atmosphere, stripping the planet of its powerful greenhouse gas blankets and converting it into weaker carbon dioxide. With the greenhouse effect shattered, Earth plunged into the deepest, longest ice age in its history, the Huronian glaciation. For nearly 3.0 times 10 to the power of 8 years, our planet was a literal snowball, encased in a sheet of ice up to 3 kilometers thick. Under such conditions, life should have ended. The ice albedo feedback loop was complete. The white ice reflected solar radiation back into space, ensuring the planet stayed frozen. It was a perfect trap. How did Earth escape this icy tomb? The savior was plate tectonics. While the surface was frozen, volcanoes continued to erupt beneath the ice. Because there was no liquid rain to wash the volcanic carbon dioxide out of the atmosphere, the gas built up over millions of years. Eventually, the greenhouse effect returned with a vengeance, melting the glaciers and releasing life from its frozen prison. Our planet proved it had a built-in thermostat, but as life evolved into larger, more complex forms, the threats became larger, faster, and infinitely more violent. Once life conquered the oceans and crawled onto land, the stakes were raised. In the last 5 times 10 to the power of 8 years, Earth's biosphere has been pushed to the absolute brink of total extinction 5 times. 5 times, the slate was almost wiped clean. The first of the Big Five occurred 4.43 times 10 to the power of 8 years ago, the Ordovician Silurian extinction. A sudden intense glaciation locked the world's water into massive ice sheets, causing sea levels to drop drastically and destroying the shallow coastal habitats where most life existed. Over 85% of all marine species vanished. Some researchers believe the trigger was an external cosmic shockwave, a nearby gamma-ray burst that ionized our atmosphere, depleted the ozone layer, and initiated a sudden global cooling event. Then came the late Devonian extinction, roughly 3.72 times 10 to the power of 8 years ago. This was a slow, agonizing suffocation of the oceans. Land plants had evolved so rapidly that their deep roots broke up continental rock, releasing a massive flood of nutrients into the rivers and oceans. This triggered massive algal blooms that consumed all the dissolved oxygen. The oceans became toxic dead zones, suffocating 75% of all marine species in a slow planetary strangulation. But the absolute worst of them occurred 2.52 times 10 to the power of 8 years ago. The Permian-Triassic extinction, historically dubbed the Great Dying, a series of colossal volcanic eruptions in what is now Siberia, forming the Siberian Traps, spewed over 4.0 times 10 to the power of 6 kilometers 3 of lava across the land. These eruptions ignited massive ancient coal beds, releasing billions of tons of carbon dioxide, methane, and toxic sulfur dioxide into the atmosphere. The global temperature spiked by over 10 degrees Celsius. The oceans warmed, lost their oxygen, and turned into boiling acid. Anaerobic bacteria in the deep seas flourished, producing massive clouds of toxic hydrogen sulfide gas that rose into the atmosphere, poisoning land animals and destroying what was left of the ozone layer. 96% of all marine life and 70% of terrestrial life died. Life was hanging by a single fragile thread. And then, the famous one, 66 million years ago, a rock the size of Mount Everest, nearly 10 kilometers wide, slammed into the Yucatan Peninsula. It struck with a kinetic energy of 10 to the power of 8 megatons of TNT, equivalent to billions of Hiroshima bombs detonated simultaneously. The impact vaporized the limestone bedrock, shooting billions of tons of sulfur, and soared high into the stratosphere. The sun was blocked out entirely, plunging the planet into a nuclear winter that lasted for years. Without sunlight, plants died. Without plants, herbivores starved, and the predators followed. The age of the dinosaurs was brought to an abrupt, violent end. When you study these 5 events, you notice a terrifying pattern. The universe did not just graze us. It hit us with everything it had, yet, after every single reset, life didn't just crawl back, it flourished. It adapted. How did the Earth, as a system, manage to self-regulate and recover from blows that should have left it as dry and barren as Mars? The threats our planet faced in its youth were local. But as our solar system orbits the supermassive black hole at the center of the Milky Way, it travels through uncharted, hostile territory. Our solar system moves at a speed of 230 kilometers per second, completing one galactic orbit every 2.310 to the power of 8 years. Along this journey, we encounter invisible executioners that we cannot see coming until it is too late.